Chapter 12 Summary. Wireless NICs. Wireless deployments require a minimum of two devices that have a radio transmitter and a radio receiver tuned to the same radio frequencies. And devices with wireless NICs, a network device such as a wireless router or wireless AP. Wireless home router. A wireless router is commonly implemented as a small business or residential wireless access device. The wireless router advertises its wireless services by sending beacons containing its shared service set identifier. Devices with wirelessly discover the SSID and attempt to associate and authenticate with it to access the local network and internet. Most wireless routers also provide advanced features, such as high-speed access, support for video streaming, IPv6 addressing, quality of service QoS, configuration utilities, and USB port to connect printer or portable drives. Wireless access point. While range extenders are easily to set up and configure, the best solution would be to install another wireless access point to provide dedicated wireless access to the user devices. Wireless clients use their wireless NIC to discover nearby APs advertising their SSID. AP categories. These are standalone devices configured using a command line interface or a GUI. Autonomous APs are useful in situations where only a couple of APs are required in the organization. A home router is an example of an autonomous AP because the entire AP configuration resides on the device. If the wireless demands increase, more APs would be required. Wireless antennas. Omnidirectional antennas such as the one shown provide 360-degree coverage and are ideal in houses, open office areas, conference rooms, and outside areas. 802.11 Wireless Topology Modes. Wireless LANs can be accommodate various network topologies. The 802.11 standard identifies two main wireless topology modes: AD, HOC mode, and infrastructure mode. Tethering is also a mode sometimes used to provide quick wireless access. BSS and ESS. A BSS consists of a single AP interconnecting all associated wireless clients. Two BBS are shown in the figure. The circles depict the coverage area of the BBS, which is called the basic service area. If a wireless client moves out of its BSA, it can no longer directly communicate with other wireless clients within the BSA. 802.11 Frame structure. Frame control. This identifies the type of wireless frame and contains subfield for protocol versions, frame type, address type, power management, and security settings. Duration. This is typically used to indicate the remaining duration needed to receive the next frame transmission. This is usually contained the MAC address of the receiving wireless device or AP. Address 2. This is usually contains the MAC address of the transmitting wireless device or AP. Address 3. This sometimes contains the MAC address of the destination, such as the router interface to which the AP is attached. Sequence control. This contains information to control sequencing and fragmented frames. Address 4. This usually missing because it is used only in AD HOC mode. payload. This contains the data for transmission. FCS. This is used for layer 2 error control. CSMA or CA. WLANs are half-duplex, shared media configurations. Half-duplex means that only one client can transmit or receive at any given moment. Shared media means that wireless clients can all transmit and receive on the same radio channel. This creates a problem because a wireless client cannot hear while it is sending, which makes it impossible to detect a collision. Wireless Client and AP Association (SSID). The SSID name appears in the list of the available wireless networks on a client. In larger organizations that use multiple VLANs to segment traffic, each SSID is mapped to one VLAN, depending on the network configuration. Several APs on a network can share a common SSID. Password. This is required for the wireless clients to authenticate to the AP network mode. This refers to the 802.11a, b, g, and ac or AD WLAN standards. APS and wireless routers can operate in a mixed-up, meaning that they can simultaneously support clients connecting via multi-standards. Security mode. This refers to the security parameters settings such as WEP, WPA, or WPA2. Always enable the highest security level supported. Channel settings. This refers to the frequency bands used to transmit wireless data. Wireless routers and APs can scan the radio frequency channels and automatically select an appropriate channel settings. The channel can also be set manually if there is the interference with another AP or wireless device. Passive and active discover mode. In passive mode, the AP openly advertises its server by periodically sending broadcast beacon frames containing the SSID, supported standards, and security settings. In active mode, wireless clients must know the name of the SSID. The wireless client initiates the process by broadcasting a probe request frame on multiple channels. Split MAC architecture. A key component of CAP-WAP is the concept of a split media access control. The CAP-WAP split MAC concept does all the functions normally performed by individual APs and distributed them between two functional components. AP MAC functions. Beacon and probe responses, packet acknowledgements, and retransmissions, frame queuing, and packet prioritization, MAC layer, data encryption and decryption. WLC MAC functions. Authentication, association, and reassociation of roaming clients, frame translation to other protocols, termination of 802.11 traffic on a wired interface. DTLS encryption. DTLS is a protocol which provides security between the AP and the WLC. It allows them to communicate using encryption and prevents eavesdropping or tampering. FlexConnect APs. There are two modes of operation for the FlexConnect AP. Connected mode. The WLC is reachable. In this mode, the FlexConnect AP has CAP-WAP connectivity with its WLC and can send traffic through the CAP-WAP tunnel. As shown, the WLC performs all its CAP-WAP functions. Standalone mode. The WLC is unreachable. The FlexConnect has lost or failed to establish CAP-WAP connectivity with its WLC. In this mode, a FlexConnect AP can assume some of the WLC functions such as switching client data traffic locally and performing client authentication locally. Frequency channel saturation. Wireless LAN devices have transmitters and receivers tuned to specific frequency of radio waves to communicate. A common practice it is for frequencies to be allowed as range. Such ranges are then split into smaller ranges called channels. Channel selection. A best practice for WLANs requiring multiple APs is to use non-overlapping channels. For example, the 802.11b or G or N standards operate in the 2.4 GHz to 2.5 GHz spectrum. The 2.4 GHz band is subdivided into multiple channels. Each channel is allotted 22 bandwidth in it's separated from the next channel by 5. The 80.211b standard identifies 11 channels for North America as shown. Plan A WLAN deployment. The number of users supported by ALAN depends on the geographical layout of the facility, including the number of bodies and devices that can fit in a space. The data rates users expect the use of non-overlapping channels by multiple APs in an ESS and transmit power settings. Wireless security overview. A WLAN is open to anyone within range of an AP and the appropriate credentials to associate to it. With a wireless NIC and knowledge of cracking techniques, an attacker may not have to physically enter the workplace to gain access to a WLAN. Interception of data. Wireless data should be encrypted to prevent it from being read by eavesdroppers. Wireless intruders. Unauthorized users attempting to access network resources can be determined through effective authentication techniques. Denial of service attacks. Access to WLAN services can be compromised either accidentally or maliciously. Various solutions exist depending on the source of the DOS attack. Rogue APs. An authorized AP is installed by a well-intentioned user or for malicious purpose can be detected using management software. DOS attack. Improperly configured devices, configuration errors can be disabled by WLAN. A malicious user intentionally interfering with the wireless communication. Their goal is to disable the wireless network completely or to the point where no legitimate devices can access the medium. Accidental interference. WLANs are prone to interfere from other wireless devices including microwave ovens, cordless phones, baby monitor, and more. That's all. Thank you.